Worked with Couchbase. Oh, you did? Wow, that's nice. How many people with some or the other NoSQL system? Which one? Mongo? Okay. Redis? Somebody? Okay, so let's talk about Couchbase Server. So what I'm going to do in the next 45 or 50 minutes is going to introduce Couchbase Server, and let's talk about data modeling for Couchbase Server. That is data modeling with JSON documents. Okay, so what are the things that we'll be looking at is I'll introduce Couchbase Server, talk about formal data modeling, talk about JSON design in particular, okay, talk about data nesting, what's the importance of data nesting and how we go about it, and some data modeling techniques that are very specific to Couchbase, that is like key design, and what are the various trade-offs that you need to do while you're doing JSON data modeling. Okay, so these are the various things that we'll be covering. So about me, I work for Couchbase. I work as a senior instructor with about 12 years of experience in professional teaching, curriculum design, and consulting. So that's what I do, and I do a lot of university teachings as well, and I have a Ph.D. in computer science from Christ University in India, and I'm a hardcore dog lover, so that when I'm not in front of the computer, I'm with my dogs. Okay. All right. So what is Couchbase? Couchbase is the fastest NoSQL database server that's available, so to perform at scale. Okay, so what do we get with Couchbase Server is you develop with agility and operate at scale. So what does that mean? So what do you mean by develop at agility? So you have multiple data models and different index types that you can have. Different data types in the same bucket. Okay, so that's what a bucket is like a database, not really a database because there's actually an impedance mismatch. So the closest thing to refer to a bucket is like a database, and we have a new language called as NQL. Okay, N1QL. It's pronounced as NQL, which is an SQL-like query language, but works on JSON. Okay, so it's SQL but works on JSON. So any database for that matter had to give working with querying facilities, right? So Couchbase just thought, okay, why should we create our own query language? Why not leverage the existing SQL knowledge of the developers and bring it to NoSQL? And that's what is NQL. Okay, so NQL N1QL is like non-first query language. And we have a built-in workbench as well. So let me just show what I mean by that. So if you just get into Couchbase Server, so you have the query tab here. Okay. So if I just do a simple thing, select star from sample, it's just like a NQL query. This is a NQL query, but it looks like SQL, isn't it? So when I say sample here, sample is the bucket. It's like the database here. So if I just go here, the various buckets that I have, Couchbase is not slow, the internet here is slow, okay? Okay, so all right, so you see the various buckets here. I have an employee bucket, like a database, okay? Sample. So you can have different data types within the bucket. So let me just go to the query here and say select star from sample, and I execute it, and boom, oh, you get an error. But look at the beauty of the error. It itself is in JSON format. So what you can do, you can just take the NQL query APIs. If you get an error, just send it back to your client, and in your client you can just pass this JSON. So what it basically says is you have to create an index. So you need an index on any bucket to query using NQL. So I'll just say create primary index on sample. That's the bucket name, and let me execute. So it takes a while, and it executes, and let me just say the same query that is the earlier query, select star from sample, and boom. So there are no documents there maybe, so that's why, but you can query everything, so everything comes as JSON. So let me just say a query from travel sample there maybe, travel sample limit 1, and let me just say something. So you can see you get data based on like JSON, right? And you can do any kind of querying there. So let's consider where type is equal to something like this. So where type is equal to root or route or whatever. Okay, So let me just say limit 1 again, because there are a lot of documents. So now you can see you still get a JSON document, but with the type is where the type is route, based on some querying. So it is a very flexible query language that works on JSON. Okay, so that's the power you get, and you have everything. You have joins, you have nest, you have unnest. So you have everything that SQL gives you, plus additional things that you require to work on JSON, because JSON has an impedance mismatch with the relational database, isn't it? So JSON has a different structure. Like JSON, you have arrays in JSON, you might have nested objects, array of objects in JSON. So Nickel gives you capabilities to query, all such things. So you have capabilities to work with arrays. So Nickel gives you that flexibility. So that's what I meant by develop with agility and operate with scale. So when we talk about scale at Couchbase, so we talk about push button scalability. So how do you, not long ago, maybe about 10 years ago, you remember the days, right, when you had to bring down your system, add one more node, so there is a downtime, and then restart, and then things work. So that's the way how you scale. But what happens today is we need push button scalability. So all you have to do is, so currently if you see my setup here, if you see my server setup, I have a 6-node cluster, 6-node Couchbase cluster. So this is all set up on AWS. So all I have to need to do, if I have to like scale down or scale up, let me say if I have to scale down here, so I have to just click on remove. I'm going to remove this node, and I'm going to rebalance. So when I'm rebalancing, you can see it's push button scalability. So I have 4-node cluster or 6-node cluster here. I'm scaling down to 5-node cluster. So it's all on, but and moreover, while it is rebalancing, you can have data that's being flowing around. So everything works fine. So no problem with that. So that's what is push button scalability. So consistent high performance. Okay, always 24/7. You have HA and DA features available, and extremely easy administration using web UI. So that's what you get, and that's an thing about Couchbase Data Platform. So if you look at the Couchbase Data Platform itself, so at the infrastructure level, you can use your own hardware, or you can use any of the cloud providers. You can use Amazon or Google Cloud. You're free to use. You have the scale-out architecture, and Couchbase is memory-first architecture. So whatever you write to the memory first, and then it gets eventually stored in the disk. Okay, so that's the way how Couchbase works. So that makes it like very good, database where you require extreme fast in-memory access, like caching. It works really well with Couchbase. And over your Couchbase database engine, you have various things like querying, that is querying with Nickel. You have search capabilities, that is, you have something called a CBFT, Couchbase full text. So in case of full text search, like what you do using Elasticsearch, right, you can do with Couchbase, and it's built within Couchbase. CBFT is definitely not a replacement for Elasticsearch. So for high-end capabilities, you probably require Elasticsearch. But what I tell about CBFT is extremely good, or it is like 20% of Elasticsearch that you require 95% of the times. Many of our customers require Elasticsearch, just for doing some kind of basic search capabilities, and that can be well done now with Couchbase Full Text or CBFT. And you have mobile and IoT based applications also that we can run. We have Couchbase Mobile 2.0, which uses the sync gateway to sync with the Couchbase server. So that's all new thing. And we have Couchbase Analytics also. So for any kind of analytical processing, but it's still in developer preview. Okay. So that's what is like the Couchbase data platform. And so this is what is used to that's where Couchbase is used to deal with systems of engagement, and that's what makes Couchbase as the industry's first engagement database. Okay. So more things on the operational part. You have you can work with the data, you can work with the query, you can maintain indexes, you have search capabilities, you have analytical capabilities. So how do we do that with the nodes is we offer different types of nodes. Okay, so if you go to my thing here, so let me just stop rebalance here. Okay, and even cancel this. So if I'm actually looking at this, I have 4 data nodes here. I have 4 data nodes and 2 nodes that are query and index nodes. So when I'm adding a node, when I'm adding a node here, say add a Couchbase Server node, I can choose, okay, what type of service that I want that node to offer. So if you look at typical data workloads or database workloads, there are three types of database workloads. You have data workload, you have index workload, and you have query workload. Okay, these are three typical workloads that you have in a database. And now we categorize that as three different services. You have data service, you have index service, and you have query service. Okay, so other than that, we also have the full text service and the analytics service. So that's the new one like I was talking about. So these are different services that we offer, and you can see since we are a distributed system, we go with the scale out approach. Okay, but there's a challenge here when you talk about scale out approach. Your whole objective of scaling out is you want to scale out the data, right? So you want more processing of the data, and that is why you add more nodes and scale out. But unintentionally, what is happening is you're even scaling out your index service and your query service. Correct? These are the three workloads that you have: index, data, and query workload. Your whole objective is to scale out your data workload. But what is happening unintentionally? You're scaling out all the three things. So that's where we come up with the new thing called as multi-dimensional scaling. So what is multi-dimensional scaling? Multi-dimensional scaling is a feature which offers you to independently scale your data, query, and service and index workloads. So that is, you can see here, node 5 through 8 actually offers your data service. Node 3 to 4 offers your index service, and node 1 and 2 offer your query service. So what's the advantage you get with multi-dimensional scaling is, typically what happens with your data workloads, you want to add more data nodes, right? You want to have 16 nodes as data nodes, you want to have 32 nodes as data nodes. But what about index nodes? Do you want to shard your indexes everywhere? Not really. You want to keep your indexes in 1 or 2 powerful nodes, which means you want to keep in 1 or 2 vertically scaled nodes. Right? So what happens? You can independently scale them up. So when you want to scale them up, when you want to scale out your data service, you're adding one node, and you're scaling up your index service. That is, you're adding more RAM or adding more capacity there. So that's the advantage that you get. So in my case here, what you can see here is, so in my case here, you can see I have 4 data nodes and 2 nodes that are both running index and query. So the reason why I did something like this is, since I have only 6 node cluster, I wanted high availability. So if this fails, probably the indexes should be present here. If this fails, the query should be able to execute here. Okay, so that's a typical structure of a real-time cluster. That's how you are, especially if you have only like 6 nodes or something. You don't have 32 nodes where you can have 2 index nodes and 2 query nodes separately. Okay. All right. Also, we have cross data center replication, where you can replicate your data across the data center. So for various reasons, you want to do that for high availability and say any kind of DR as a DR solution for disaster recovery. All right, let's talk about the main stuff here, that is data modeling for Couchbase. So now that you know a bit of Couchbase, so let's talk about data modeling for Couchbase. So what data modeling is? There are various definitions for data modeling, but what I actually feel is data modeling is nothing but designing the data the way how it best suits your application. Okay, so that's what is data modeling, designing the data that best suits your application. That's what is data modeling. So data modeling is essentially a progression of, from conceptual data model to logical data model to physical data model. So that is how you go. So where conceptual data model is like a 10,000 feet overview of your data, how your data looks like, right? You use ER diagrams to represent that, and you don't have to know what's the underlying database that you're using. You use Oracle or you use Couchbase, it doesn't matter. But when it comes to physical data model, you'll have to understand your storage system. How it stores the data. For example, Couchbase is a document database, and it stores as key and value. You have a key and you have a value. And it's also nice to understand, especially when you're data modeling for Couchbase Server, you really have to know the strengths and probably the weaknesses of Couchbase Server itself. That is, it has key value orientation and it is memory first architecture. So the other advantage is it leverages the JSON flexibility. So Couchbase can store any kind of data. It can store XML databases, XML documents, it can store normal strings, it can store binary documents, it can store serialized objects, it just can store anything. But most likely you're going to store your JSON data. So also Couchbase Server is like geared for JSON. So when I say geared for JSON, all the tools that are getting developed over Couchbase, on Couchbase, assumes that you're kind of storing the data in JSON. Say for example, Nickel, right? So when you're creating an index, you're creating an index on a particular attribute in Nickel, right? So it assumes that you're storing data in JSON format. You can query distributed data using Nickel. So the Nickel is the newest language that we have to query data. Duplicate and nest data when it makes sense. This is definitely something that you probably don't do in your relational databases, right? So in your relational databases, what happens? You do a lot of normalization. Normalize and normalize and normalize. Why do you do that? Maybe for data consistency. Consistency could be one more reason. Or you don't want data redundancy. Okay, you don't want the repetition of data. Right? But when it comes to Couchbase or when it comes to most of the NoSQL databases, when you're data modeling, we relax the normalization. Okay, the whole idea is I want to read most of the things in one go, right? So which means what do we do is we try to nest data when it makes sense. Like for example, if you look at a music application, okay, so you have three things there. Say for example, you have playlists, you have tracks, and you have artist, right? So typical relational database, you have three tables. You have playlist table, you have artist table, you have track table, right? Playlist has track IDs, which is referring to the tracks, and tracks has artist IDs to tell who's the singer of or who's the artist of that. And then you do lots of joins to try to retrieve the data, right? So why do you want to do so much? Why can't you try to embed, the artist name, most likely which is being used, or the track name inside the playlist directly? So will it repeat the data? Yes, there might be some amount of repetition of data, but probably some kind of sensible repetition of data is always fine. Because, for example, the artist name doesn't change, right? So when will the artist name change? It doesn't change. So it does make sense to embed the data so that when you retrieve the document, you retrieve in one go. So your gets are much faster. Right? So of course, you give up on sets there while you're trying to update the document. Maybe you'll have to update more than one document. That's one thing that you'll have to probably consider. But again, there's a trade-off there. Okay? So that's something that you'll have to choose wisely. Like how many times do you even update the artist? The artist is never updated. So why not embed it? Makes sense, right? So that's what I mean by duplicate and nest data when it makes sense, and test repeatedly to validate your design. So when we are talking about JSON document design itself, there are various things that have to be considered. First, let's talk about a little bit of JSON itself. So of course, JSON is now has now thankfully replaced XML as the most common format that you use. You use Twitter, everything, all the data is dealt in JSON, isn't it? So the advantage of JSON, it has various apps that can be used. It can be used easily serialized and deserialized. Of course, it has a number of supporting technologies also, like you have JSON path. Okay, it's like your XPath for XML. You have JSON schema. JSON schema is when you want a JSON document to conform to a particular, it's an equivalent to DTDs or schemas in your XHDs in your XML. Okay. And of course, JSON has a lot of worthy competitors like BSON, YAML, or protocol buffers, message pack, Avro. So these are various competitors that you have, and you can use Jackson or JSON, which can be used in most of the popular libraries that you have. So what are the various design choices that you have when you're actually working with JSON? Okay, so the first choice that we have is single root versus type attribute. Okay, I'll talk in detail about this. We have choices of objects versus arrays. We have choices of choosing array element types. Okay, we need to work with timestamp formats, and I think working with timestamp formats is one of the most difficult things when you do with JSON, especially because in JSON you do not have the date format, right? In Oracle you have date, right? So when you are actually comparing this date is greater than this date, it's very easy. Okay, it does all the comparison. But here the date is stored as string. So if you're trying to do this as this, greater than this, or equality, it's going to check lexicographically, and probably you're not going to get the right answer, right? So you have a lot of conversion functions in Nickel which can help you with that. We'll talk about that in a while. So, or various best practices, especially working with JSON and dates. So property names, empty versus null versus missing attributes. Okay, we'll talk about that a bit. And we'll talk also about JSON schema. So these are the various design choices that we have when we are talking about JSON documents. So what's the single root attribute versus type documents? Let's talk about these two styles. So look at, this is a JSON document, which is a track document. Okay. So the root element of the JSON document is track. Okay. And everything is within the root element, that is track. Okay. So the next way of doing that is have everything in a flat structure, but have an additional attribute called as track. Right, makes sense? So these are two different choices. I don't say this is better over that. My personal choice is the second one, because when you do type as track, you can index on that attribute. It's just about that. So you don't want to index on the root element, right? It's going to take the whole document and put it in your index node. You don't want to do that. Okay, so this is a matter of style. You can see here the root element is track. So if the root element is employee, it's an employee document. If the root element is order, it's an order document. If the root element is playlist, it's a playlist document. Okay, so how are you going to query it? Your query model changes. So in your first style, the query says select star from the bucket name dot track. Okay, I'm going to say that. Okay, or I'm going to say select bucket name dot track from the bucket name. I'm going to do something like that. Okay, or select track dot star, or select track dot type from the bucket name. I'm going to do that. Okay, depends on version of Nickel also. In latest version, we are trying to formalize. We have only one format which says like select track dot star from the bucket name, and things work. Or select track dot artist from bucket name, and so on. While in the second case, what I have to do, I cannot say select track dot star. I have to say select star from the bucket name where type is equal to track, where type is equal to employee, where type is equal to playlist. So when I have the type attribute here, I have a where clause associated with that always. Right? So that's a matter of style, a choice between two documents. Okay. So let's talk a little more about arrays. So when you have to represent arrays, look at this phones. Phones is a simple object here that is embedded. So while in this case, phones is an array of objects. So again, this is a matter of choice that you have. So when you're doing this, again, your object model can change. Your object model will have your class user profile, and inside your class user profile, you'll have phone as an object. But in the other case, you have class class user profile, and then you have an array list of phones. Right? So that's going to be something like that. So that's again a choice. Array element types. So when you have an array something like this, you can just have an array of strings something like this, or you can have an array of objects. Now there is a lot of advantage of the second one over the first one. So just imagine, let's consider the earlier scenario that we had. We have playlist, tracks, and artist. Okay, so if I have an array of tracks, okay, with say 10 IDs, okay, and I have to get the say playlist name, the track name, and the artist name for all the tracks, I have to do 21 gets. 21 gets. Why? So each document, I have to first read this playlist document, and for each track document I have to read the track document to get the track name, and for each artist ID in the track document, I have to get the artist name. So I have to do 21 gets to do that, right? But let's consider, when you're doing array of objects. So if you had embedded, here it's a simple one, if you had embedded the track name and the artist name, all you have to do is one get. Inside this, if I had embedded the artist name and the track name, that is here, if I had embedded the artist name and the track name, all I have to do, I have to just read the playlist and I have all the information that is required, one get. You might be thinking, it's not really a big thing, but let's consider you have 1 million users and million users are trying to get the whole thing. So million users into 1 is like 1 million gets, while million users into 21 is like huge, right? So that's going to be a lot, 21 million gets. So it matters there, right? Timestamp formats, working with timestamp formats, you at least have 3 options, especially when you're working with timestamp formats with JSON. So one way is to store in simple ISO 8601 format. You can do that. Or you can store it as epoch format, that is the Unix style. Or you can store it as the array of time components. Okay, the array of time components, when you store it like that, it looks funny, but it can be extremely useful, especially when you are trying to generate some kind of time series graph. Okay, and you want to push it to say Tableau or some kind of visualizer tool to do some kind of visualization. It works really well, especially when you are actually grouping. It makes a lot of sense to use to represent time as an array of time components. Okay. So many people, especially when they use Couchbase, they store time in more than one format. They store in this format, that is ISO 8601 format, as well as the Unix style format, because this is like super easy for doing some kind of comparison, right? Especially when you want to sort it by descending order or ascending order. So especially you want to do the appointments or the orders, you want to sort by ascending order or descending order. It's very easy. You just take this and sort by descending. So that's going to work. Right? Well, this is not going to work. This is a simple string. But this could be a good display format. Okay? So whatever you want to display it, you just keep it like this. And for any kind of processing, you store it in epoch format. So that can work. Choosing with property names. So choose meaningful names. Be consistent in your coding standards, that is country underscore code versus country code. Probably we prefer this if assuming most of them are Java developers. And array types, you keep it as plural. All property names should be singular. And you try to avoid reserved words, especially when you use nickel, right? So if you use reserved words, you'll have to enclose them within backticks. Okay, and avoids hyphens also if possible. Empty versus null versus missing attributes. So JSON supports optional properties. So that's the beauty of JSON, right? Flexible data store. So it can have optional properties. 2 JSON documents might not be exactly similar. So that's why you go there, isn't it? There might be some properties that are missing. So if a property has null value, you can actually consider dropping it instead of having a property say country : null. Instead of having that, you just drop that attribute at all. You don't want to have that attribute at all unless you really have a good reason why you shouldn't drop that. Okay, and nickel makes it extremely easy for testing for null and missing values. Okay, that is you again have extra syntaxes. That is, I can say select star from Couch Music 1 where user profile dot gender is missing. So I get all the documents where user profile dot gender is missing, right? So there are 3 things. Is empty. So empty basically means just double quotes, that's empty. And you have null. Null basically means you have explicitly typed it as null. Or you have missing attributes. Okay, the attributes that doesn't exist in that document, right? So a very good example is some employees have children, some don't, right? So you can actually query it, okay, where children is missing in employees. So that's going to get you that data, okay, which is again the capability of nickel specifically, okay. So of course here nickel handles that. At your application end you are going to handle that, okay, because that attribute is not going to come down there. So you'll have to ask, okay, if that attribute is null, okay, only then parse it, You'll have to make sure that it is handled by your application code. Okay. JSON schema. So talking about JSON schema, Couchbase Server absolutely pays no attention to the shape of your JSON documents as long they are well formed. So all it checks is a well formed JSON document, it's done. It doesn't care what is within that. Okay. But sometimes what happens, it makes sense that you want to validate your JSON document so that it conforms to a particular shape. Okay. So that is when you can use JSON format, and JSON, that's where you can use JSON schema, which is JSON based format for defining the structure of your JSON, like your XSDs or DTDs, you know. Okay, and there are various implementation in different programming languages, and you can have a look at that with jasonschema.org. Okay, and that's an example. So look at this. I don't know if it's like pretty visible there, but you can see this is a JSON structure, JSON schema, which in itself is JSON based. So I define various properties. Like, what are the various properties? I say country code is a property, GDP is a property, name is a property. That is your attributes, right? You have population, region number, type, updated. These are the various attributes that I can have in my JSON document. And what are the various constraints of that particular attribute? Okay, the minimum length is this, the maximum length for country is this. Okay, so 2 and 2, which means it has to be exactly 2 characters, country code. GDP, it has to be an integer and minimum 0. So these are the various constraints that I'm giving. I can specify various types. It can be array, boolean, integer. You have a number of types that you can choose from. Okay, and you have various validations. That is, you can have the minimum, maximum, length, minimum length, format, various patterns that you can use. Okay, and then out of these properties, what are the various required properties? These are my required properties. Okay, and out of these properties, can you have additional properties? No, false. Okay, I don't want to have any additional properties, only these fixed properties. Okay, so that's an example of JSON schema. However, remember, again, Couchbase Server does not pay any attention to this. This has to be done at your client side. Okay, this implementation is at your client side. Couchbase Server absolutely pays no attention to what the shape of your JSON document is. Let's talk a little bit about data nesting. That is what we call it as denormalization or relaxed normalization. So you can see, as you know, relational database design promotes separating data using normalization, which does not scale. So what we do with NoSQL system, we often avoid normalization, or we relax normalization. Okay, we don't avoid normalization, we rather relax the normalization so that we can scale. And nesting is the way how you can do that. You can do multiple levels of nestings also, but typically you don't do more than 3 levels of nesting, because it's going to increase the complexity of the document. But however, it is like very use case specific. So I have seen users doing up to 12 levels of nesting, but I think that's too much of nesting, not required. But we, as a rule of thumb, we just keep as 3 levels of nesting as max. Okay. So we a lot of time include the timestamp also in nested data. Okay, so that you can make sure that you have your parent and the child, which are like synchronized kind of thing. Okay, because especially Couchbase Server does not support transactions, right? One way of doing that is by embedding the timestamp. Okay, and double checking, okay, whether both the timestamp are same. If both the timestamp are updated and to be the same, it's like, okay, the whole cycle is done. So you basically read your own write once again to check if the whole thing is over. That's one thing. Okay, people get a lot of concern with transactions. Okay, oh, it doesn't support transaction, then my whole thing is gone. No, it's not really. But when you look at a typical enterprise, right, I was reading an article which says 1 million reads that are done, or 1 million workloads that are done, is non-transactional. It's like 1 million is to 1. So 1 million non-transactional workload and 1 transaction happens. Okay, and just because of 1 transaction, you want to shift your whole workload of 1 million non-transactional aspects to, say, something like relational database is not a great thing. So you need to see an alternative for that. All right, so let's look at data nesting here. So in this case, you can see you have a playlist and the user profile here. So you can see the owner here within the playlist document. You have the owner attribute. The owner attribute is cross-referencing the username here. Okay, the owner attribute is cross-referencing the username here. So which means if I have to read the username of the playlist, I have to do a join. Okay, or I have to get the playlist and get the username and get the other document. Correct? So, but instead of that, okay, what I could do is, instead of just embedding the owner details there, why not do a little more? That is, most frequently accessed information. See, it's partial embedding. I'm not embedding the whole document. The whole document is there, user profile document. Instead of that, I've taken only a partial document and I've tried to embed here. That is, I want to embed the name, the first name, the last name, and the title. That's about it. Oh, but if you want to know the phone number of that person, oh, you do a next get. If you want to know the email address of that person, okay, you do a second get. You know, the whole idea that I want to give you here is the most frequently accessed information. Okay, you keep it in, you try to nest it. There might be a whole set of information that you don't want to access it, isn't it? Say, for example, let's you know, take a quick thing. Say, let's consider you are in the airport, okay, and you listen to nice music. What's the first question that you ask? It's a nice music. What's the first question that you ask? Hey, maybe nice song. Which song is this? Or who's the artist? Right? That's the question that comes to your mind. Do you ever get, hey, nice song. What's the artist's date of birth? Do you get that question? No, you don't, right? So, you know, the most frequently or most required information, you try to embed the artist name. Okay, the artist email probably you want that, you know, whatever you require there. But if you want the whole set of information, that is anywhere there. So instead of going with this, where every information has to be accessed, okay, or stored in a different document, you do some kind of nesting here. Okay, so that is there a duplication of data? Yes, there is. Okay, but this is what is sensible duplication. The whole idea is here is when you read the playlist, you get the name of the owner, the last name of the owner, the email address of the owner, and so on. Right? So one get instead of say two gets that you have to do. The same thing here, to take another example. So look at this, what's happening. You have playlist, and inside playlist you have track IDs, which is, you know, a typical relational database design, isn't it? So of course that's a JSON document, but it's a very typical relational design, and everybody does that because we are lot allergic to repetition of data. You know, the first way how you do is you don't repeat data, isn't it? Even you do NoSQL, because we have been doing, you know, this normalization ever since probably you did in our school, right? We have been doing that from last so many years, and it's very difficult to unlearn that and you know, shift ourselves to repeat the data. So you'll have to tell yourself a lot many times that it is all right to repeat the data, right? So here, look at that typical database design, where typical relational design. So where you have playlist, and in the tracks, tracks is an array of strings, or tracks is an array of track IDs, right? So if I have to play these tracks, I have to get the playlist, and for each ID, I have to get the tracks. So in this case, 3 tracks, I have to do 3 additional gets. Instead of this, probably, if I had partially embedded this, that makes more sense. So look at that. So now that you have, you know, playlist information, you have partial track information also. That is the artist name, the genre, the MP3 location, the ID of the track, and the title of the track. That's what you require most of the times. So now to play these 3 tracks, you have to do only one get, that is get the playlist. Only if you have to require additional information about those tracks, okay, what's the length of the track? Okay, maybe I have to do an additional get, which is very not so often that you request for, right? So that's the whole idea of nesting, okay? So you do a lot of nesting, okay, to avoid additional gets. Talking about key design, so in Couchbase, it's a key value pair, right? So what are the best practices for key design? So if you look at the typical document in Couchbase, so if I just look at any document, okay, let me just say sample. So I have a couple of documents here. So I don't have any documents here. Okay, so let me just say, oh, that's why, my first query, it didn't happen. So I have employee here, so it has couple of documents here. So you can see here, this is the key and this is the document. Okay, so very simple document here. The key is 101 and the value is these documents. So let me just run that query again, the first query that we didn't run. So I can create primary index on employee is the database, and oops, sorry. Okay, and yeah, let me execute that is select star from employee. Okay, and you can see the results are in JSON format. Okay, so you can do any kind of query where salary greater than 3,000 or something. So you should be getting 2 documents. So only 2 documents that you're getting where salary is greater than 2. But you can see the nickel query is executing on JSON documents. That's the beauty of it. Okay, and lots of things that you can do. I was talking about the missing thing, right? So let me show the missing attribute here. So if you look at my employee documents, I have a couple of employee documents. I have the second document with user colon 102, where look at this, I have the country attribute here. Okay, for all the other documents, I don't have the country attribute. Okay, so what I can do here is, so I can just say select star from employee where country is not missing. So where country is an attribute is not missing. So I get only one document where country attribute is not missing. The country attribute exists. Okay, so where country is missing, so I get 4 documents. Okay, other than 102, which is Puneet's document, other than that, I get all the other documents. It's a very, very simple way of looking at what missing is. Of course, it has a whole set of features. You probably have to go through all this, and it's extremely fast. Like, how do I demonstrate how fast is that? So I have a very simple 4-node cluster. So what I can do is probably I can log into my AWS here. So I'll do an SSH of that, and okay, I'll do, let me log into the root and let me go to opt Couchbase bin, and let me work on CB workload gen, which is the workload generator. I want to generate random workload on Couchbase. Okay, so what CB workload gen is, I give the number of documents it has to generate and it randomly generates. So -b the bucket name. So I want to generate documents in sample bucket, and how many documents, -i. Okay, the number of items I want to submit as say 100,000 documents. So look at that, it writes 100,000 documents now inside sample bucket. So when I look at the sample bucket, so it's not refreshed there, but it actually has 100,000 documents. Okay, I told Couchbase is fast, okay, but internet is slow, unfortunately. Okay, so here you have 100,000 documents. 100,000 documents where you can see the content is like the binary content. But if you want to generate JSON content, all I have to do is -j. It generates random JSON documents. Okay, so 100,000. Look at that. It's like boom, right? 100,000 JSON documents, sample JSON documents. Okay, so just sample JSON documents. This is the key and this is the value. And you can see I generated 100,000 JSON documents. Right? You probably want to see how fast it was. Probably instead of 100,000, probably I'll generate 1 million. Okay, so that you can actually go through what's going on. And so let me actually go here to the sample document here. Okay, internet is slow again. I hope it doesn't finish writing before I show you something. Because Couchbase is fast, right? Oops, it doesn't open. Oops. Look at that, it almost finishes writing. Oops. Okay, I think internet is not working. So that's all right. Maybe in the meanwhile, if it opens, I'll show you that. Okay. Okay. So looking at the key design here, we have your employee documents, right? So we have your employee documents. And to look at the key design, you can see here I have user :101 instead of just 101, right? So that is a key pattern that we actually choose. So how do we do that? So usually keys are formed primarily with natural keys. So natural keys are something that exists from your real world, because the fastest way of accessing Couchbase is by the key. Okay, you know the key, you get the data. Okay, nickel is there. Nickel is very nice, okay, but definitely slower than key. If you know the key value access, okay, if you know the key, you always access. So access using the key. So your first objective of designing a document should be such that it gets accessed by its key. So which means probably if you know the phone number of the user, so user : phone number is a very good candidate of a key instead of having user : a random UUID, right? Because you're not going to remember random UUID. How does your app work? Because you're logging using the phone number, and you have the phone number, and you do a get of that particular document, you get the entire document, right? So that's way faster. So example is like phone numbers, usernames, social security numbers, account numbers, you know, UPC, QR codes. These are like the natural keys. It's often the first choice for document keys. So, but definitely you'll have to be very careful with the personal identifiable information. You don't want your SSN number to be shown in your browser, right? So where search.jsp ID is equal to your SSN number. You don't want to do that. So you'll have to be careful there. So when there is no obvious natural key, okay, you can have a surrogate key as well. That is, which is not derived from your application data. They can be generated values. Example is your SHA, UUIDs, okay, or Couchbase also supports atomic counters. It's just like your sequences. So various key value patterns also that we actually use. We typically use something like that: user profile : something that is user : 101, employee : 101, okay, pizza : 102, some things like that, which identifies which document it is. Okay, you can give a full qualified name, which typically enables multi-tenancy with Couchbase. So if you have multiple tenants, you can say, okay, pizza : user profile : 101, McDonald's : user profile : 101. Two different tenants, user 101, same user, but different tenants still, right? So it gets accessed in a different way. So that's also quite possible. And a lot of times when you want to store the history of the document also, you can do parent and child relationship. Okay. So that's something that's possible also. So there are various trade-offs that needs to be done, especially when you are actually working with Couchbase or JSON documents itself. What are the various trade-offs? I just took the dictionary definition of what trade-off is. So it says a situation in which you must choose between or balance two things that are opposite or cannot be had at the same time, right? So you have two things. You want to choose the balance because now you do not know that you can, you know now that you cannot have both the things at the same time. Okay. So what are the tough choices that you have to do? Okay, the toughest choice was choosing between the CAP theorem. Okay, between CAP, you want CP, AP, or which is the other one? CA. Okay, you'll have to choose either one. Does somebody know what is Couchbase? Is that a CP or a AP system? AP? No, Couchbase is CP. It's consistent and partition tolerant. It gives up on availability. Okay, so we'll talk about that outside if you want. Okay, because Punit is almost like showing his cards behind. Okay, so we'll talk about that as well. So Couchbase is a CP system. Okay, so that's the toughest choice to be done, and that's already done by Couchbase. What are the choices that you have now? You have various choices of choosing between the document size, the atomicity, the complexity, and the speed of access. These are the various choices that you have. Because see, we talked about nesting, isn't it? So you do more and more and more of nesting, what happens? The document size becomes bigger, right? It's nice that you can get the whole document within one get, okay? But what happens? The document size becomes bigger. When the document size is bigger, it takes more time to transfer over the network. It takes more time to serialize. It takes more time to deserialize. So that's the trade-off there. Okay, when the document size is bigger, the speed becomes slower. Your whole objective was to embed so that you have faster access, but unfortunately you get slower access because the document size has become way too bigger now. Right? So it's a wise decision to choose how much you want to to be made of, how much you want to embed and how much you want to refer. That's what you'll have to choose. That's the choice. Okay, those are the tough choices that you have to do. Document size, atomicity, complexity, and speed. Okay, so document size, the maximum document size in Couchbase is 20 megabytes. Okay, does not mean that you have to have documents, all documents which are as big as 20 megabytes. Okay, Couchbase is extremely good with accessing or working with documents that are of relatively small size. Okay, what is relatively small size? It's again relative, okay, to the customer itself. For me, if you ask a general number, any document that's greater than 30 kilobytes is a large document for me. Okay, but we have customers who have stored more than 100 kilobytes of data. I have a customer who has stored as large as 7 megabytes of data. Okay, that's huge. Okay, you don't want to do that. So if you're dealing with documents that are potentially large, you definitely have to test thoroughly for the speed of access. So it of course depends on the speed between two Couchbase server nodes. Typically it's like a 10 gigs line, that's what we recommend. People can have 40 gigs line, 1000 gigs line also if you have money, right? So typically it's like 10 gig line. On a 10 gig line you do not want a document that's as large as 1 MB to be going around in and out. Okay, that's large. Okay. So you also want to limit the number of dependent child objects so that you know your document size. What I mean by that is, so in your playlist, when I'm embedding tracks, right? So it's going to increase your document size. But at your application level, if you have a constraint saying that, okay, my playlist does not have more than 50 tracks, okay, that's going to limit the size of the document. That makes sense. Okay, you do not want a playlist like my favorite playlist with 10,000 songs, right? It cannot be a favorite playlist, right? So and that's going to have a large document size also. That's not possible. The choice of atomicity, Couchbase is atomic at the document level. So if you want transactional kind of thing and you want to be completely atomic, you have to make sure all the changes are within the same document. But that's not possible many times, isn't it? So Couchbase Server does not support transactions. However, they can be simulated if you have to write additional code. Okay, you'll have to write additional code to implement it. So if you absolutely need changes to be atomic, then it'll have to be a part of the same document. Okay, and the maximum document size of Couchbase Server may limit how much data you want to store in a single document. That is not more than 20 megabytes. Complexity is another choice that you want to do. So it affects various systems, including data modeling. So look at a typical query here. So I'm not going to explain that query, but what I want to say is you do not want a query like that. Okay, that's a very, very typical query where you have joins, where you have nest, where you have unnest. You don't want to do so much, right? That's not a very nice thing. So you want your document to be like fairly sized, such that you can do a very simple join if required, or try to access directly using the key. Okay, so that should be your objective. And the last thing here is the speed. So when it comes to data modeling, speed is extremely critical. So various things. The first way of accessing the document should always be by your key, because that's the fastest way. Second way is have some kind of appropriate indexes. We have covering indexes. We have MOIs, that is memory optimized indexes, where your whole index is in your memory. So which is like extremely fast. That is the second option. Third option is the GSI, that is global secondary indexes, so which is disk based indexes. And the last one, the slowest one, is the primary index, which actually I showed you, right? So that's the slowest one. So if implementing an interactive use case, you'll want to avoid using joins. Joins are cool features of Nickel, but they are slow. So you want to use them wisely. Do a lot of duplication when required. Okay, and we also have views also, which is like your materialized views in your relational database. So when you do not want up to a second accuracy, so you can use views as well. So with all these things, we roll out to a single question: whether do you want to embed or you want to refer, or when do you want to embed and when do you want to refer. So when do you want to embed is when the reads greatly outnumber the writes. There are many reads than the writes. So you want to embed, you want to do it in one get. Okay, and you're comfortable with slim risk of inconsistent data, which is not really true, which you can get over it by doing, read your own writes and maintaining timestamp between parents and child, and you want to optimize speed of access. Okay, and when do you want to refer? When consistency is a priority, when you want to use cache effectively, so smaller documents, which means more documents in the cache, right? And the embedded document you feel is too large and complex, so you want to refer them to make the documents look much simpler instead of more embedding. Okay, so with this, what's next? Actually, we have a lot of free online training that we offer, excellent free online trainings with the labs, so you should visit training.couchbase.com/online. Okay, so that is hands-on training, absolutely free. Okay. And you also have classroom trainings, which you can do, go again to the same link, that is training@couchbase.com. We have the developer training, we have the data modeling training, we have the ops training. Okay, and that's the summary of that. And I'm open for questions if you have any. Thank you. Yeah. Yes, replication, there are two types. One is within the data nodes, and one is you can have cross data center replication. So replication within the nodes, what happens, you can have 1, 2 or 3 replicas. 3 is the maximum replicas that can happen. So what happens, the copy of one node is stored in other nodes. So when a node goes down, depending on whether you have auto failover enabled or not, the replicas become active. Right? But in case of cross data center replication, it is across the data center. Okay. So you can use it for HA or DR purposes. Yes, sir.
You mentioned that Couchbase is memory first.
Correct.
So does it mean, so in hypothetical scenarios, obviously not, we are using like write once, right concern?
Yeah.
Does it mean that accepted and acknowledged write may be lost?
That's a good question. For that, we have a lot of persistence parameters also. That is, you don't have to it's of course memory first, you can't change that, okay? So, but you can also have the acknowledgement level, that is only when it is persisted in the disk, return an acknowledgement to the client that the data write is successful. Only when it is replicated to a node, return an acknowledgement to the client that the data write is successful. When there are only 3 replicas that are created, return an acknowledgement to the client that data write is successful. So these are the persistence levels that we can that you as a developer can choose. So by default, as soon as it is written in the memory, it returns an acknowledgement to the client that the data write is successful. Yes. Yeah. Yes. Primary index is always on the key, on the document key. Yeah, so that's going to be a secondary index. I can create index on particular sample and the type attribute. That's secondary. That's global secondary index. On an attribute, any index that's created on an attribute is a secondary index. Yes, and you should, I think, definitely go and visit our online courses, which talks about all these things. And the best part is it's hands-on and free, absolutely free. Do we have problem? No, it's extremely fast. When you have primary index, it's slow. It's very slow, because primary index, what happens, each and every document is read. It's like a full table scan. It's almost an equivalent of a full table scan. You don't want to do that. But indexes, they are maintained using GSI, which is we use ForestDB for that currently, which is a different data structure, and they are like super fast. It's in terms of milliseconds and nanoseconds. All right. Thank you very much. Thank you.